Hello, and welcome back. Today we're going to be talking about outliers. What is an outlier and how do we find an outlier? So the first thing I'm going to show you is the definition of an outlier and an image of that definition. An outlier is a value that lies outside most of the other values in the set of data. Now if you take a look, there's a number line, and each one of those orange points represent a particular item or point from a set of data. And as you can see, there's one that's all the way by itself in between 9 and 10 on the number line, and it's labeled the outlier. So you notice there's a huge chunk of space between that and all the rest of them, and all the rest of them are rather closely bunched together. That's what makes that an outlier. Right. Now, how we find an outlier, or how do we find an outlier? It's pretty simple. It's a three-step process. One, order the data from least to greatest. 2, examine the spacing between the elements in the data set, or pretty much examine the spacing between the numbers. And 3, look for the number that is far removed from the others. So order the data from least to greatest, examine the space between the numbers, and 3, look for the number that's far away from everybody else. Alright, so I'm going to show you how we do this. And as you can see, I have an example on the screen. I have a set of data, 25, 29, 3, 32, 85, 33, 27, and 28. And we're going to look for an outlier. Now, if we take a look at the set, we're going to do the first step, which is order the numbers from least to greatest. So I'm going to go ahead and order the numbers. And it is now going to be in order of 3, 25, 26, 28, 29, 32, 33, and 85. And now the set of data is in order. Next step is we're going to examine the spacing between the elements. Now there's a couple ways to do this. You can either use a number line and plot all the points, or you can actually see how much each one goes up, like between 3 and 25, that went up 22. 25 and 27 then went up 2, 27 to 28 then went up 1, 28 to 29 again 1, 29 to 32 you add 3 to 29 to get 32, 32 to 33 you added 1 to get up to that one, and from 33 to 85 you had to go up 52. Or you can look and plot all the points on the number line, which as you can see to the right I have all the points plotted, and as you can see right above them I have the plus and how much they increased by. So with that, we can look at the spacing between. And that's what I mean by the spacing, how far apart they are on a number line, or how far apart, like as in how much you have to add to the previous one to get to the next one. So now that we have that set up, and it's up to you how you want to set it up, either you can look at it graphically on a number line, or you can actually do the math and write out how far they are. And then from there we can move on to step 3, which is look at the number that is far removed from the others. Like which one is far removed? And if you take a look, this set actually has 2. Either you look at the number line and see that the majority of the points are between 20 and 40, and they're rather bunched up together. But we have this point that's really close to 0, and this other point that's in between 80 and 90 that's pretty far apart. So you can see there's a huge jump there. And if you look at the actual spread, how we did it on the left, you see that plus 22 and plus 52 is far beyond plus 2, plus 1, and plus 3, which is everything else. So we actually have 2 outliers. And those outliers is 3 and 85. That's how we find an outlier. We order the data, we look how far spread apart, either by seeing how much you have to increase to get to the next one, or putting them on a number line. And then from there, you see which one is far away from everyone else, and those are your outliers. Alright, so our answer, again, is 3 and 85. Right, that's all there is to it. Order, examine the spacing between the numbers, pick the one that's farthest away, and you have an outlier. Now, not all sets have outliers, just to let you know, but some do. And this is an example where we had 2. Alright, so now that we've gone over those together, I want you to go ahead and try some out on your own. I have 2 sets of data. When I tell you to, I want you to pause the video, find if there is or if there isn't, and if there is, what is the outlier or outliers for these sets of data. All right, when you have your work done, you got your answers, unpause the video and come back and we'll go over it together. So go ahead and pause the video now. Alright, welcome back. As you can see, I have the original problems on the screen. And here is my work. I just used the spacing because I didn't have enough room to put both up. So I ordered the data sets for both of them. For number 1, it turned to 12, 34, 34, 35, 44, 45, 52, and 56. For problem number 2, it changed to 2, 3, 4, 4, 4, 4. I think I had all 4 fours said. 5, 6, 9, and 21. Now that I've done that, I'm going to examine the spacing. As you can see, I have an image right below the ordered set where I do that. I see I have a plus 22, 0, plus 1, plus 9, plus 1, plus 7, plus 44. I'm sorry, plus 4. And for the second one, I have a plus 1, plus 1, plus 0, plus 0, plus 0, plus 1, plus 1, plus 3, plus 12. Alright, once to that, I'm going to pick the one that's farthest apart from each one, and I see that the plus 22 and plus 12 is indicating far spread apart. So that gives me an answer of 12 for the first one, and an answer of 21 for the second one. Alright, and that's how we figure out the outliers. Alright, so if you have any questions, send me an email, or you can play back this video. And other than that, have a great day. We'll see you next time.